In the last part of this video, I said that when someone creates a frequency distribution table, the person lists out every number in the x column from the lowest value to the highest value and not skipping over any numbers. But in some situations, you're not going to want to list out every number from the lowest up to the highest because the column would end up being too long. There would be too many numbers to list out. And an example of when that might happen is if someone is doing a survey of a random sample and the person is asking for ages. If a person is asking people for their ages in a random sample, it could be that the lowest person is 18 and the highest person is 100. And if that's the case, you're not going to want to list out every age all the way from 18 to 100 because your frequency table would end up being very long. You'd have a very long X column, and it would take forever to read it. So in that situation, what you would do is create something called a grouped frequency distribution table, which has groups or in the X column rather than just numbers. So here's an example of a grouped frequency distribution table. What we've done here is we've put decades in the X column, and we've put the frequency of each decade in the F column. So what this is saying here is that um, in the data set, there's one number in the tens, five numbers in the 20s, three in the 30s, four in the 40s, and two in the 50s. So it's the frequency of this category over here. It's not the frequency of just one individual number. And I actually don't have a data set for this to go with. So I just put this table here as an example, but I don't actually have the data values listed out anywhere on this slide. But I already just explained to you what this is showing, so I think you get the idea. So now let's go over a little bit more vocabulary because a grouped frequency distribution table has some vocabulary that goes with it. So the first term we need to understand is a class interval. So in a grouped frequency distribution table, each um, each of the entries in the x column is called a class interval. So if we go back to this table right here, 10 to 19 would be the first class interval, 20 to 29 would be the next class interval, and 30 to 39 is the third class interval. So each of these is called a class interval. I think you've probably heard the word interval before, maybe from another class or at some point in your life. And an interval is a span of numbers, right? It goes from the lowest end to the highest end of the interval. So each of these is an interval, right? 10 to 19 is an interval, 20 to 29 is an interval, and it just happens to be that we call them class intervals in a grouped frequency distribution table. I'm not sure where the word class comes from, but just don't worry about that. And the size of each class interval is called the class width of the table. So if we look at each of these class intervals, like 10 to 19, 20 to 29, 30 to 39, notice how each one of them covers 10 numbers, right? Because there are 10 numbers between 10 and 19. There are 10 numbers between 20 and 29, and 10 numbers between 30 and 39. So what you would say is that this table right here has a class width of 10 because each interval covers 10 numbers. And it might seem like each interval covers 9 numbers, but it's actually 10 because, well, between 10 and 19, you have 10, and then you have 11, 12, 13, 14, 15, 16, 17, 18, 19. That's 10 numbers. And it's important not to confuse the class width with the frequency. So the frequency is the number of times that the class interval appeared in the data. So if the data set has 4 numbers that fall into the tens, then 4 is the frequency. But the class width is the the total number of numbers between this low point and this high point of the interval. So, um, so this class interval has a width of 10 because there's 10 numbers between 10 and 19, and it does, and the width is 10 regardless of how many times it appears in the data. And if now let's imagine that these intervals had been 0 to 99, 100 to 199, and 200 to 299. Well, then the table would have a class width of 100 because each interval would have a span of 100 numbers. And now imagine that the intervals were 0 to 999, 1,000 to 1999, and 2,000 to 2999. Well, then each interval would cover 1,000 possibilities, which would mean that the class width would be 1,000. And it turns out that there's actually a formula that can give you the class width. So if you want the class width of a class interval, you don't have to actually count the number of values between the lowest end and the highest end, like I've been doing, because that can be really long in some situations. So this formula will give you the class width. What you do to get the class width is you take a number called the upper boundary, subtract it by the lower boundary, and add 1. So I'll explain what I mean by lower and upper boundary. Here's our first example. So imagine we have this table right here, this frequency table that I've just shown you, and we want to get the class width. Well, what we would do is we would just focus in on the first class interval, 10 to 19, and the higher end, which is 19, is our upper boundary. The lower end, which is 10, is our lower boundary. So we take those numbers, we subtract the upper boundary by the lower boundary, and we add 1 at the end. And, well, 19 minus 10 is 9, and 9 plus 1 is 10. So in 2 steps, it gives us our answer of 10. And I told you earlier that the answer is 10, and I explained why it's 10, but now you can see it being done with a formula. So notice how we've used the same formula I showed you up here. We took we subtracted the lower boundary by the upper boundary. I'm sorry, we subtracted the upper boundary by the lower boundary and added 1 at the end. And you have to add 1 to account for the fact that 10 is actually included as part of the interval. If you didn't add 1, it would be a 9, which isn't correct. Okay, and you actually don't have to use the first interval. You could use any interval you want to do this. You just have to pick one. For example, I could have taken 20 to 29 and done 29 minus 20 plus 1, and I would still get 10. Or I could have taken the third class interval and done 39 minus 10 plus 1, and I still would have 10. So really, you just have to pick an interval and then use it. But the most convenient thing to do, I think, is just to pick the first one, like I did. So that's how you get the class interval. I'm sorry, that's how you get the class width. So here's one more example. Here's another table. We can already tell it's going to be a class width of 50, but if you want to see it with a formula, it would be 49 minus 0 plus 1, which is 50. 49 is our upper boundary, 0 is our lower boundary, and upper minus lower plus 1 is 50. That's how you get class width. And now let's talk about how to create a grouped histogram. So I mentioned earlier, and I think in the last part of this video, that a histogram shows the same information as a frequency distribution table. Well, a grouped histogram shows the same information as a grouped frequency table. So once again, we're going to just be making a bar graph that shows the same exact information that the table shows. So let's see, I think what I actually did here was I took the same table. No, actually I didn't. So this is just an example for you to refer to. It's not based on any problem that I have in this video. It's just meant to show you the idea of the group histogram. But if this was a real data set, this would be saying that the data set has two numbers in the tens, three 20s. No, I'm sorry. Um, two numbers in the tens, three numbers between 20 and 24, two numbers between 25 and 29, and one in the 30s. And I want to point out that I actually I actually didn't do a very good job of making this table because um, when you make a grouped histogram, all of the intervals are supposed to have the same width. You're actually not supposed to switch from a class width of 10 to a class width of 5. You're supposed to keep the same class width all the way across. So what I should have done is I should have made this 10 to 19, 20 to 29, 30 to 39, 40 to 49. But like I said, this graph right here is just a picture that's meant to explain the definition of a grouped histogram. It's not, it doesn't correspond to any example that I have in this video. It's just an introduction to the concept. Okay, and now in the next part of this video, I'm going to talk about the purpose of a histogram, why a histogram is actually useful.